I am graduate from architecture, hoping to be and willing to be a space architect so soon, maybe later. And I'm leaving the field to our moderator, Gülşah. It's with you. Thanks a lot.
Okay. First of all, welcome and thank you for attending our panel. We are coming from the different parts of the world, and the thing that brings us together is just science. So we can say that the science is too universal thing that, and anyway, we can say basically this one. I want to introduce the panelists to each other. I want to start with Bailey Burns, I'm sorry. Bailey, I read that you were a system engineer at Paragon Space Development Corporation with a history of working in mechanical engineering in space industry. And also you are the founder of A Space Story. Do you want to talk about it a little bit?
Yeah, thank you guys. I'm really excited to be here. That's all correct. I'm a systems engineer working on the life support system for the astronauts for one of the lunar lander proposals for Artemis. So we're keeping the air clean, making sure the pressure is good, making sure the astronauts can breathe, basically. So it's really, really interesting work. And I started A Space Story as a way to kind of counteract all that engineering stuff I'm doing. I like being creative, I like writing, I like having fun and meeting people. So A Space Story is a way to do that all around, you know, learning each other's space story and stuff like that.
Okay, thank you so much. Erin Shepard, do I pronounce it true? Erin Shepard is with us.
Yes.
Okay, so you're a robotic engineer, and you are the founder of Cogito, the company dedicated to inspiring through STEM outreach. And you were building the robots that you can control with your mind.
Yep.
Am I right?
Yep.
I stalked it. And also, there is another fun fact about you. You have 6 fingers each of your hands. You wanted me to edit, so I'm sharing it with others.
Yes. So, I have a bunch of different experiences. My original background was in biochemistry, and I was in medicine for a little bit, and I decided that I wanted to do space stuff because space is a lot more fun. So I went back to school. I'm currently getting an electrical engineering degree now. In that process, I've actually interned at NASA 3 times, and I worked on 2 different robotics projects. So they were really, really fun. And yeah, like you mentioned, Cogito was my way to kind of get out of all the engineering stuff and just to build cool robots. And so, yeah, I started building robots and experimenting with brain-computer interfaces, and now I can control things with my mind. And I want to share that with the rest of the world and use it to get people inspired in science and technology. And so I don't actually have 6 fingers on my hand right now. I was born with 6 fingers, but they took them off as soon as I came out. So I still have my fingers. They're like in my baby book at my mom's house, but now I just have 5 now, so regular person.
Okay, thank you for informing us. And we have Giulia Bassani with us. Hi, welcome. And you are a student of aerospace engineering, and your goal was to being an astronaut, right?
Yeah.
And you are the owner of 2 space books.
That's true.
You want to talk about it?
Yeah, sure. So yeah, I'm studying aerospace engineering, and I'm about to get my bachelor degree hopefully soon. And I'm also a Mars researcher, as I'm in fact now working on 2 different researches, one on cosmic radiation, which is such a big problem for space missions, and the other on space sustainability, which will be super important for long-term missions to space and to Mars and the Moon in particular. And I wrote 2 books because writing has always been one of my biggest dreams, and so I kind of found a way to merge my passion for writing and for space, because one of my books is set on Mars while the other is about aviation. The protagonists are pilots. So yeah, that's pretty much it.
Thank you for informing us. And we have Zahra, Mary, Ronizi with us. Can I see you? Oh, okay, I saw you. You're coming from Miami, Florida, and you traveled a lot around the world visiting numerous space centers and several space camps to learn more about space exploration and to pave your path to becoming an astronaut. After attending multiple space academies, you were sure that space was a career you wanted to pursue. So you were able to start training to become an astronaut, am I right? And also you have a license of PADI scuba diver, and you are training for pilot, right? You want to talk about it?
Well, thank you. Hi, everyone. I'm Zahra, and I'm an astronaut trainee from Miami, Florida. And since the age of 5, I've dreamed and aspired to become one of the first humans on Mars and to be an astronaut. And since then, I've been training and building up my experience, you know, going to different space academies, getting my scuba diver's license, and I'm currently training to get my private pilot's license. And I've just been building up my experience and, you know, getting my name out there so that one day I could hopefully be an astronaut. And I'm very interested in medicine. So I've been working on an experiment that I've been developing that maybe I get to test within the next 1 or 2 years. And so in the future, I'd like to go into medical school and become a brain surgeon. And one of my biggest dreams is to study space medicine and hopefully one day perform medical research on Mars.
I hope so. And the last one is Ali Khorshidi, or am I pronouncing it right? You're with us. And you are the Master of Aerospace Engineering, also major in Flight Dynamics and Control from University of Tehran. And you are the translating, collecting, and writing scientific articles, right?
Yeah. Can you hear me?
And I'm sorry? Yeah, I can hear you. Yes,
Yeah.
I can. And
Okay.
you are writing some articles, right? Amateur.
Yeah,
Okay,
I'm an
you can
amateur
continue.
science journalist. Yeah, let me say hello to you, Gülşah and Elif, and all Stardust Squad. Good night. I'm really happy to be with you guys in this webinar. As you said, yeah, I'm writing some articles since I was 16, and I'm really interested in promoting science, especially for kids, for youth, and this program is about that.
Yes, it is. So you want to start with your presentation?
Okay. I don't know other guys are ready to start or not, but I'm going to start introducing myself. Hello again, I'm Ali, 26 years old, and I have master's degree in aerospace engineering, measures in flight dynamics and control from University of Tehran. I'm also technical committee member of RoboCup, Asia Pacific competitions and RoboCup Iran Open competitions since 2012. And like all of you, I'm a space lover, and I also in love with space and in love with robotics. I have been very interested in robotics and aerospace since I was a child, just like 7 years old, and I have pursued both until today. I continued one at university and academically, I mean aerospace engineering, and the other experimentally in the form of the job and businesses. Like many of you, I put in a lot of effort because I love it and I want to be successful, and I'm trying to be a successful man. For the last 3 years, I have been working for an active and famous company here in Iran in the field of robotics and industrial automation called Pish Robot. My job and position is head of advanced technologies. Our main focus is in education, robotics education, and STEM, or science, technology, engineering, art, and mathematics, STEAM or STEM. We have various agencies and schools throughout Iran that train students interested in robotics. And my job is to study new methods, new platforms, and directly oversee the R&D unit. Prior to this position, I was in charge of advanced coding department and was responsible for producing and supplying coding training contents for kids and for youth, building the coding platforms like build a coding robot, and working with MIT Scratch software and setting up a coding department in general. Currently, one of my tasks is to developing Scratch Tree, MIT Scratch Tree, a software that for kids coding based on MIT's work. And I'm trying to connect virtual world to the real world, to communicating with the real robots. And kids really enjoying to controlling robots via a computer and coding blocks. Okay, in Pushro, I'm also in charge of training and training of some special courses like ROS or ROS, Robotic Operating System, and so many other special courses. But let me turn to my curiosities in the world of space technology. From the age of 9, when I fell in love with the space, I saw books, magazines, and various movies, and I tried to learn and learn and learn. In high school, I really wanted to gain some experience in space technology, but one of the problems with the space science and any high technology in general is that that is not easily accessible, especially for a high school student at the time. In my research, I noticed an interesting type of project called near space satellites. There are some pseudo satellites that are taken to the height of 30 kilometers by the weather balloons and fall with some parachutes, and we will recover them and gain some and collecting some data from the micro SD card or other platforms. At the university, I became a member of a university CANSAT team in the first semester when I was just near a student. And I don't know, you know about, you heard about CANSAT or not. But CANSATs are the satellites are same with the near space satellite that I mentioned before. And people launch them via a parachute, via weather balloons, or via sounding rockets to lower altitude, and we will recover them, and we will read the sensors and some weather sounding and etc. And the CANSAT should transmit us some data to the ground station. It is in my opinion, if you're young and if you are a student, be sure to go for making some CANSAT, and I can help you too. I will tell that in the next. And besides robotics, I was still active in the field of space, and with the CubeSats project, everything became much more serious for me. And I don't know if you heard about CubeSats or not, but remember I said that every advanced technology is usually not readily available or accessible for us, for the public, for the normal peoples. But CubeSat are one of the best projects that make space accessible for us, for the students, for the youth, and young people. And I really suggest to gain some experiences about CubeSat and find some information about CubeSat and start to studying about them. CubeSat have a history of 20 years and formed precisely with the aim of providing cheaper and easier access to the space for students since 1999. And they are cube-shaped satellites that are approximately 10 by 10 by 10 centimeters in size and in the weight of less than 1.3 kilograms. And we call them 1U CubeSats, although larger size such as 3U are more common now, is in exempling 30 by 10 by 10 centimeters cubic. It is good to mention that not all the parts and equipment we use on the ground, such as sensors, microcontrollers, etc., can be used in space. But CubeSats make and sets a new standard that you can use most parts and use most of the sensors and available components in the regular bazaars for making a real satellite, a real one satellite that can work and really work, and it will orbit in sun synchronous orbit or SSO orbit in 500 kilometers orbit. Usually and commonly, and on the other hand, because the physical dimensions and volume of these satellites, 10 by 10 by 10 centimeters, they are really small, and launch cost is much less than a real large satellite that you may know. Although this cost may be high for individuals, it may be too high for me as a aerospace engineer, as an aerospace student, but it is very affordable for research and academic plexes, for the universities, for bringing valuable experiences. Also, I should mention that CubeSats are requiring electronic knowledge, programming, mechanics, thermodynamics, physics, and other fields. And of course, aerospace engineering, and you can build a team and make a team in your university with these aspects and with these experiences. But if you are new, I have a better suggestion. I have a more affordable suggestion, and we call pocket cubes. Pocket cubes are a smaller version of CubeSat in the size of just 5 by 5 by 5 centimeters in cubic shape. And they are really, as I mentioned before, they are really small, and making them is really cheap. You can build one in $50. If you can build one in just 300 euros, and it depends on the mission of your satellite. The cost maybe go higher or lower. Their standards and rules are much simpler than CubeSats, and this is a good news for newcomers and newbie people to experience this space more simpler, more and more simpler. In Iran, I and one of my colleagues held online classes and workshops in space engineering, space system engineering, satellite engineering, and space orbital mechanics based on SDK software, AGI SDK software. And due to Corona pandemic, we held them online in my website. And it was a really great experience. The courses was open to the public. It's in the premium, but in a very low price. It was a really great experience for the first time in our country, and from students from all over the country participated in these courses on my website, and they were in various fields of studies, and it was very well received. No, I haven't at the end of my presentation type and end of my talk. I have a special offer for you and for all Stardust Squad and all our guests today and tonight. It's just suggestion. I just think about that, and we can hold the English and international versions of these courses that I mentioned above, just like satellite engineering, space system engineering, CubeSats, Pocket Cube, and of course robotics, online and based on a webinar type, like in Zoom, like Adobe Connect on my website. To the help of the Stardust people, Stardust Squad, who wants to experience space more simpler. And we can do that, and we can hold these webinars and these courses freely, or with, and some of them for very, very low cost, maybe as much as 2 McDonald's sandwich, of course, and this cost is more related to the cost of the internet and my server and infrastructure. Thank you very much. I'm ready to help who wants to experience space, and you can be in touch with me via my social networks, via my email, and thank you for your attention.
Thank you for informing us. And anyone wants to speak, or anyone wants to ask some questions to Ali? Nobody? Who wants to speak? Secondly, Giulia, you are coming from the same department with Ali, so anything you want to add him?
Okay, you can hear me now. He mentioned about CubeSats, and in my university, which is the Polytechnic University of Turin, there is a CubeSat team that I think it's pretty known. Yeah, and they are working on several missions related to, please ignore my cat on the background. Okay.
It's really cute.
No, he's really annoying. And I know that they're working on several missions. I think they also were planning on sending the CubeSats to Mars, which was pretty impressive. And also, since we are on the theme, in case any of you is interested in studying abroad, do come to the Polytechnic University of Turin, because it's so cool and it's open to international students. And if you want to join the CubeSat team, also you're welcome. So yeah.
Okay, thank you. And
as you can see, it is my CubeSat on my hand. It's my master thesis project. I don't know you can maximize my image or not. But it is a ADCS subsystem, or attitude determination and control system of a CubeSat. The CubeSat that I mentioned in 10 by 10 by 10 centimeters in 1U CubeSat, and it's an engineering model, not a flight model, of course. And I'm gonna testing it for verifications, and I will. And next, I will design it and build it for a real flight model. But it's truly working, and it can control the satellite by this magnetic coils. You can see here two in X and Y axis and one in Z axis, hide by the power subsystem. And you can not so easily, but you can experience it in university by a team. But I built this individually because of some of my experiences in electronics. I can build this satellite alone and individual, but you can experience and enjoy to build a satellite with your friends, with your colleagues in the university and in the college. Thank you. Sorry.
Okay, thank you. And there is another founder of Cogito. I want to talk to you. What about your robots? I saw them and these seems really successful.
Like, do you want to see a robot, or are you just asking about them? I'm a little confused.
I'm asking about them, and also I saw them, and if you have any examine with you, you can show us, of course. Okay, so I didn't bring any examples with me today. They're actually sitting in the lab, which is my garage. But if you go on my social media, I post about them all the time, and they're really, really cool. So just to give you guys a brief background, like I mentioned earlier, I'm really into robotics. I have always been into robots and intelligent machines ever since I was a little kid. I wanted to build robots specifically to explore space. And I was really, really passionate about watching the astronauts launch up and watching them go to the International Space Station and all, and off in the shuttle and all that cool stuff. So my freshman year of high school was in 2004. And that's when they announced that they were going to cancel the shuttle program. So that meant that there were no astronauts that were going to launch from the United States ever again. And at the time, a lot of people thought that that was the end of NASA, that was the end of space flight, that was the end of the space age. And for me, that was really, really devastating because I was like, oh my gosh, what am I going to do with my life? I can't. I want to work in space, but by the time I finish university, space flight won't exist anymore. So a big lesson that I always like to tell people is don't trust everything that you hear word of mouth. A lot of times, and especially when it comes to aerospace, there's just the industry works in its own unique way. And a lot of times the everyday person doesn't really know what's going on with NASA. They don't know what's going on with the European Space Agency or JAXA. It's all speculation. And so just because you hear somebody say, oh, well, the space industry isn't going to exist or it's not going to be successful, don't listen to them. Find out for yourself. Because what I ended up doing was I ended up saying, okay, well, let me go become a doctor. And then I got into, I studied, I got a degree in biochemistry. I actually got into medical school. I was sitting in class and I watched the European Space Agency land on a comet. And as I was watching them land on a comet, I was like, oh my gosh, people are totally still sending stuff to space. Like, why can't that be me? And so after thinking about it and after, doing a little bit of soul searching, I left medicine. I said, I don't want to do medicine. I want to do engineering, and I want to do, just like when I was a kid, I wanted to go back and do space robotics. And so in that process, I started my engineering degree. I'm still going at it now. I will finish eventually. It's a little hard. I forgot how hard math was, but, as I was doing my engineering degree, I actually got involved with a research team at my university that designed tentacle robots. And my project was to design a tentacle robot that could wrap around satellites and CubeSats and other objects in space. So that way we can bring them back to, for repair or to deorbit them. So I don't know if you guys know this, but there's a really big problem right now in that there's a lot of debris that's stuck in orbit around the planet from when we were launching stuff back in the 60s, 70s until now. And that debris is traveling super fast. Then it's 17,500 miles per hour. I can't remember what that is in kilometers per hour, but it's something like what?
maybe like almost something crazy, like almost 30,000 kilometers an hour, which is really fast. And if it hits the International Space Station or if it hits an astronaut, that's going to be a very, very bad day. So my robotics project, or my project, was to design a robot that could catch all of that debris and keep the astronauts on the ISS safe. And from there, I ended up getting multiple offers to work at NASA designing different robots for them. So I designed robots that would work together to build habitats on the moon. So for all of you space architecture people that are in the audience, like I got to get involved with something like that, and it was really cool. I also designed robots that would work together to help build solar panels on the moon, so that way astronauts can have power to whatever habitat gets built. So, and in taking all of that experience and that passion for robotics, I just began experimenting with my own designs. And I got really interested in a thing called a BCI, or a brain-computer interface. And essentially what that does is it's a little headset that you can wear, and it measures the electrical activity that is in your brain. So if you've ever had like a sleep study done, or if you've ever had to get like it's an ECG, I think. It's the thing that they put on your heads, and you see the graph, and it's all the waves. And those waves are actually representing what's going on in your brain. And so you can get a BCI for really cheap. I found some as cheap as $20, 20 American dollars. So I can't translate that into Turkish currency, but they're not expensive at all. And so with that, I began experimenting, and I learned, I made some modifications to the BCI, and I was able to actually take the data that it was reading, and I was able to pipe it out to whatever system I wanted to. And with that, I started using my brain data to control robot motors. And so I had the robot that my company designed, the first robot that we designed, actually, if you make yourself focus really hard, the robot moves itself forwards. And if you get relaxed and all zen-like, then the robot will make itself go backwards. So just by changing the way that you thought, you could actually change the direction that the robot is heading in. And an interesting thing with that is, at first when I made the robot, and again, so one thing I really want to express to the audience is that with science, it is such a beautiful thing, especially if you love it, because in a lot of cases, something that you're just making or designing because it's fun can actually be used to help solve a greater problem for the rest of society. And in my case, I didn't think about this at the time. I was just building robots that I could drive with my brain. And I was like, oh, this is cool. But people told me, especially students that suffered with attention deficit disorder, attention hyperactive deficit disorder, they said that working with the robots really helped them. And it really helped them learn what it felt like to focus on something. And it helped them learn how to focus. And so with that, I decided to launch my company, Cogito, and our main goal is to take this BCI technology, use it to inspire people into science and technology because it's just really cool. But then B, we want to use it as a tool to help students that struggle with ADD, ADHD, who have trouble focusing in the classroom. And it's just like an exercise to like, okay, so everybody, like, raise your hand if you've seen Star Wars. Okay, so Star Wars? Yes, Star Wars. Like, come on, everybody's seen Star Wars. I know you guys have seen Star Wars.
I didn't.
You didn't? What? Okay, that's your homework. You have to go watch Star Wars.
Okay, my first mission is this.
Yes. And so if you remember with when Luke is doing the Jedi training and he's using the Force and things are moving and reacting based off of him thinking about things moving, that's essentially what my company is trying to recreate, but in real life. And we don't do it with magical midichlorians or space wizard stuff. We do it using science and technology. And so that's, and again, like at the time, I had no idea that what I was working on could be used in such a broad way. So I definitely encourage everybody in the audience, whatever it is you're passionate about, follow it, and, you know, keep following that passion. And who knows, you could create something that could ultimately change the world. So that is ultimately like why we should want to do science. We have the ability to make the world a better place. If you think about it, think about how much technology has changed the history. And so it's an honor and a privilege to be a part of the movement to help advance technology and advance society even further. And I know this is a space conference, so I will say that my goal is to still continue to work in space robotics. My company, I would love to see this. I would love to get this technology in space with the astronauts. I think that there are a lot of applications from actually helping the astronauts while they're out doing their EVAs or their extravehicular activities in space. And also, even if they're just sitting in the station and they want something to do, moving things with their mind sounds like a great way to keep them entertained. So yeah, that is all about my company, all about the robots, the story of how we got there, and some of the lessons that I learned along the way. So yeah, that's all I have.
That is so great. And Zahra, do you want to talk about, you are probably going to be the first Mars walker. What do you feel about it?
Well, I might not be the first, but I've been training and working to, you know, hopefully be on that first mission and maybe the first human on Mars. We never know. But so what I wanted to talk about was medicine, because space medicine, because, you know, growing up, it's clear I've been talking about it, that I've been like a freak about space, and I've been so obsessed with the stars and becoming an astronaut. However, at the same time that I was, you know, dreaming to be an astronaut, I was also dreaming to be a doctor and medicine, and it was always, you know, something that I studied. I always watched videos on medicine and different surgeries. So as I was growing up and I was meeting different people in the space industry, I've seen that almost everybody is studying, you know, aerospace engineering and physics and astrophysics, which I absolutely love. But at the same time, I was a bit confused about how could I do medicine and astronautics at the same time. I was a bit confused, and I felt like I had to give up one of the two. But as I grew up and I started researching more, I've read the stories about several different astronauts that are also doctors, like astronaut Mae Jemison and Canadian astronaut David Saint-Jacques. And as I met these people and I was, you know, researching what they were doing and what specialty they got into, I really started to see that, wow, actually medicine is really important. Not only, you know, in space, obviously there's so many changes on the human body when astronauts go to space for 6 months at a time, but also the doctors and the, you know, the people in the medical field that are also training to be astronauts and that have gone to space before. So for me now, what I've been doing is just studying more medicine and trying to see how I can correlate that with my astronaut training. And so, as I mentioned earlier, I've been working on a research project that hopefully I want to publish one day about sutures in space. And what's so important about sutures is that so far when we've gone into space, we've been pretty lucky, you know, with the Apollo missions, the space shuttle missions. We haven't had many injuries, severe injuries in space where, you know, the astronaut's life was in danger. But now that we're preparing to go to Mars, it takes 6 to 8 months just to get to Mars, and then we'd have to live on Mars for a year, maybe 2 years, and then another 6 to 8 months to get back. And this is just for a round trip. If we stay on Mars forever, it's going to be, you know, even worse. So it's going to be pretty impossible that we get to space, we get to Mars, and we live there without having any injuries or any casualties. You know, there could be flying debris that punctures the spacesuit, and, you know, we have an open wound, or someone might lose a limb. So, you know, I've been researching and working on an experiment about sutures in space. And so far I've been learning how to do sutures, different types of sutures, you know, like stitches. So if there's an open wound, and if an astronaut has, if they cut their head open or they have like a wound on their arm, you know, the astronauts can learn to sew and to do sutures. So, you know, with this experiment that I've been doing, hopefully I'd like to maybe go on a microgravity flight and test that in actual microgravity. And so this, once I publish this, it's really going to relay onto the possibility of doing surgeries in space, which is going to be, you know, it's a really tough job, you know, especially with weightlessness, it's going to be really tough. But so far, I'm starting with baby steps, and maybe one day we could get to doing surgeries in space. And actually, while you guys were talking, while the other panelists were talking, everyone had some sort of an experiment that they were showing, like a CubeSat. So I just did a few sutures here in my suture kit. I'm not sure if you could see. So I've been practicing on this and learning how to do sutures, and then maybe one day on a microgravity flight, I'd be doing the same and see how does being in microgravity affect an astronaut's you know, ability to do sutures. How different would it be than being on gravity on Earth? You know, when we have gravity on Earth, it's way easier than doing it in space. So I've been studying that, and hopefully get to publish something and maybe make a change in space medicine. And another thing really that like a challenge that I've been facing, I'm 14 years old. So being so young, there are so many different restrictions, and there's always this saying that, you know, the young people, you know, they're still learning, they still have a long way to go. So, you know, a lot of the opportunities with space and, you know, doing analog missions or about a bunch of training and getting a private license, the age is so important. You know, just to be a pilot and to get your private pilot's license, you have to be 17 years old. And I'm 14 and I'm turning 15 in 3 weeks. But so for me, what I've been really working is to build my experience and build up my resume so that, you know, once I get that age and I reach that level where I could apply for all these different things, then, you know, I can get my name out there and I can increase my chances. So as a younger person training to be an astronaut, I really put out my work on social media. That's really something that I'm really been working on, you know, sharing my journey, sharing all my different experiences to encourage other young people like me all around the world to persevere and to reach their dreams. So that's been really important for me. And what I like to do, you know, this is always my motto, just put your name out there. You know, if there's an application for a job or a research position, put your name in the hat. You know, you never know what might happen. And fun fact, actually, when NASA had their astronaut applications to become an astronaut candidate, I actually applied. And obviously there's, you know, I'm 14, there's no way I'm gonna get in. You know, there's like a 99.999% chance I'm not gonna get in. But you never know, you know, maybe NASA says, oh, there's like there's children that are so interested in this stuff in space, and maybe we might have a little program for them. But so what I really like to do is just to get out there and keep pushing those boundaries, you know, even as a young person, just to get my name out there, to keep working. And so that's what I've been doing lately. And I've also been getting several certifications that are really important for astronauts to have, like a scuba diving certification and a private pilot's license, of course. And, you know, that's what I've been doing so far. And hopefully I get to be an astronaut one day and get to share my experience with the rest of the world and inspire other people like me to continue chasing their dreams.
It's going to be so exciting for you.
Thank you.
I mean, you're 14, only just 14, and I'm 21. I'm still studying at something, and believe me, it's really amazing.
Thank you.
And who else? We didn't talk, Bailey. We didn't talk to you.
Yeah, hi everyone. So I'm 24, so I'm trying to think back to 10 years ago, and yeah, it's a very different world. I'm very proud of you. You're doing super cool things for your age. So kind of speaking of that, that's kind of my background. When I was 14 years old, I wanted to be a journalist or maybe a historian. So the fact that I went full send down the engineering route was kind of unique. I got into like a really good engineering school for college, and I went in not really knowing much about engineering. So I started thinking about like, okay, well, what excites me about this kind of stuff? And I got into mechanical engineering, into aerospace, and kind of shifted this direction. So I guess that's kind of my takeaway for all of you guys is you don't have to know. You don't have to know exactly what you're doing. It's okay if it changes down the line. I also am an aspiring astronaut. I hope to go to space. I hope to go to the moon. I'm a moon girl. So that's kind of what I wanted to talk a little bit about, actually, was that kind of finding that path and everything like that. And a lot of stuff that people don't know about is something called space resources. I'm actually getting my master's in space resources right now. And it's kind of similar to, like, you know, we're probably going to have, you know, casualties in space like that. If we're living in space long term, we can't be sending everything with us. You know, that'd be the equivalent of trying to, you know, let's say you're traveling from, I don't know, I can't even think of like 2 locations, like from one side of Africa to the other. Let's say you're going from the north side of Africa down to the south side of Africa, okay? You're not going to take every ounce of gas you need with you. You're not going to take all the food you're going to be eating with you. You're not going to be taking, you have to find those things along the way. Well, in space, there's not much out there, so that's the issue. We can't take everything with us because it's so expensive to launch everything. So a lot of what we're focusing on is, okay, how do we do that? How do we get to space in a sustainable way where we don't have to take everything with us? And that's a part of that is additive manufacturing, all that really cool 3D printing stuff you see going on. There's a lot of work with like biology, plants, that kind of stuff, and actually even combining the two so that you have tools or infrastructure that is the base of it is 3D printed, and then they use plants to grow around the 3D model, and it makes it stronger. So just crazy things like this that they're really trying to figure out. They're figuring out how to do this, basically. So kind of along that line, my big interest with space resources has been the moon, obviously. And I think it's really fascinating because there's so much up there. People think it's just like a gray desert kind of, you know. There's so much more to the story up on the moon. There's helium-3, which is probably one of the most powerful energy sources that we can control right now, and there's not much helium-3 on Earth, but there's so much on the moon. We could be powering we could power the Earth for thousands of years pretty much. So if we can start figuring out how to use that, we'll be in good shape if we can figure out how to mine it and everything. We also have lunar regolith, which is my favorite thing. That's the moon dust, the moon dirt up there, and it's kind of this like blessing and a curse at the same time, where if you breathe in lunar regolith, it is basically like breathing in tiny little diamond shards, and it like destroys your lungs. If they're small enough pieces, they can actually get into your bloodstream and cause a lot of issues. And it's a huge, that's an issue. They destroy any sort of mechanism, any seal, like the seals on the spacesuit. The astronauts on Apollo could only do X amount, like a few EVA walks, because their seals were starting to fail because of all the lunar regolith. So like one of the biggest issues we're seeing is this lunar regolith stuff. But like I said, there's a blessing there that it is actually one of the most, like, it's one of the best building materials for that 3D printing that I mentioned. It's one of the best, like it's one of the best out there. It's so strong for how much you need to use, and it's on the moon. So if we can just get a printer to the moon, we can start printing everything from, you know, habitats to any sort of like roadways, anything like that. So like I said, I could go on about the moon for a while. Blessing in disguise is lunar regolith. And because of that interest I have, I'm sort of becoming a geologist now, which, you know, being an engineer, is very new for me, but I really like rocks. So if we have any rock fans out there, I didn't realize I liked rocks, but I just did something called an analog mission with a group called High Seas in Hawaii. And basically you go and you live in a habitat, basically pretending like you're living either on Mars or on the moon. And so we, you know, if we went outside, we had to wear a spacesuit. We had to eat dehydrated food like the astronauts would have to eat. And we did all sorts of experiments and stuff, very similar to what you'd be doing if you actually went to go live on the moon. So I was there for 2 weeks. It was rough. It was like quarantine times 100. It was amazing, like super difficult. But one of the things I found was lava tubes, because it was on the side of a volcano in Hawaii. So when we did EVAs, we would go we would go like into the lava tubes, which are basically like really long, deep caves is the best way to explain it. Like 200 meters long. Some of the chambers were up to like 6 meters wide, pretty much 2 to 6 meters wide. And it was really cool. It was kind of spooky, you know, if you turned off all your lights, it was pitch black and you didn't hear a sound. It was just kind of, it felt like you're on another world, you know, you're just sitting there like, I feel so small right now. So that was really cool. But through that, I realized that lava tubes are probably one of the biggest resources we have in terms of starting to build and get ready to live on other planets, because both Mars and the moon have lava tubes. And the ones on the moon are like even bigger than the ones we have here on Earth, because nothing's been there to disturb them. They haven't had any volcanic activity in a little while now. And so their chambers are like 20 meters across. And we're starting to think about, well, hey, you know, there's no solar radiation down here. There's no weathering. Everything's kind of safe. It's kind of like a little capsule. So why don't, you know, on top of all the things we can learn about the moon and how it formed, why don't we go down there? Why don't we live down there and use what the moon has to offer us, instead of trying to dig holes ourselves or trying to build a habitat on the surface or something like that? So in terms of that space architect stuff that you guys were talking about earlier, I'm all about that. Highly consider lava tubes in that little realm as well. But so that's a lot of my research right now, kind of like what I'm working on is all these big questions about, you know, yeah, we want to go to the moon. Yeah, we want to go to Mars. It'd be cool to walk around a little bit. But how are we going to get all of humanity to the moon and Mars? And how are we going to stay there and not have another Apollo? I call it, like, I love the Apollo era, but I call it an Apollo incident, where we go, we walk around a little bit, and then we just leave. No, we want to go there. We want to stay. And it's time to start figuring out how to do that. So that's a lot of what I'm trying to do. And if there's any questions there, I know that was a lot of information I just dumped. So if there's any questions there, always feel free to reach out to me. I'll take any questions right now too, but that's me in a nutshell.
Is there anybody who has some questions for Bailey? Nobody, please.
Okay, space
Okay.
rocks. That's all I have to say.
Giulia, you haven't ever talked about anything. You want to start
Yeah,
with something? You have 2 books. You
can
want
add
to talk
some,
about them?
sure. So I want to say it was funny how Bailey mentioned that she's an engineer, but now she's into geology. I can really relate to that because, as I said, I'm studying aerospace engineering, but at the same time, I've grown super passionate about biology and astrobiology, which is basically the study of the distribution of extraterrestrial life in the universe. And recently I've started astrobiology online course, which is held at the Mumbai Amity University in India, which is super fun because I found myself having classes at like 6 a.m. in the morning because, you know, the time zone and everything. So yeah, it's pretty fun because it has nothing to do with aerospace engineering, because I mean, engineering is basically engines and machines and how these kind of things work, because it's super cool, but I felt like I needed some more connection with natural stuff as well. However, I think something that might be nice to talk about is how I got into this whole space world, because actually, differently from you know, what one might expect, when I was a child, I absolutely didn't care about space. I mean, it wasn't at all one of my passions. And actually, I used to watch science fiction movies and I was terrified by them. Like, I didn't absolutely want to be an astronaut because they always ended up so badly. And I mean, no, thank you. That's not what I'm gonna do. And actually, everything started later on when I was in middle school, I think. I mean, I don't know if you know what middle school is, but it exists in Italy. I'm from Italy, by the way. And I was 13 or 12, 13, and I found myself reading a book by Stephen Hawking. And it was so crazy. I remember seeing a picture of the Hubble ultra deep field, where every single bright dot was not a star, but it was an entire galaxy, and there were so many. And I remember being incredibly overwhelmed by that picture that I almost found myself crying. it was so crazy. And that was also the moment when I decided that space was going to be part of my life. I still didn't know how, because I knew nothing about space back then, but I just decided that it was going to be. And then I kind of lost that path as I then went to high school, because, you know, you grow up, so many things change. And at high school, I had such a hard time, actually, because I had so many struggles with math, with physics. Like, I really had many struggles. I loved those subjects because I found them fascinating, but I just didn't have, I don't know, I couldn't remember formulas, or I couldn't understand. I don't know, I just, you know, the usual mathematics struggle of so many students. And I was so lost because I didn't know what to do. I didn't know what I was going to do when I was going to, you know, grow up. Then at my third year of high school, it happened that the first Italian woman astronaut went to the International Space Station. And at that moment, our physics teacher became totally obsessed with that woman. And so he continuously talked to us about her and her mission. And so that was how I got into astronautics, and how I discovered this whole world. And I mean, what really fascinated me was the whole process of actually getting to space. So the reason why I decided I wanted to be an astronaut was, yes, because I mean, floating in space and doing something that no one has ever done before is super cool, and doing it for, you know, science and exploration and progress and all of that. But what really hit me was the whole challenge that becoming an astronaut represented. It was, I mean, I'd always loved challenges, and that was going to be the biggest challenge I would ever try, you know, and it's something I'm still trying. And well, I have to say that following that dream is what helped me overcome my struggles with mathematics, because thanks to that, I finally had a real motivation to get to work and to study, to learn, to fight, you know, through all of that. And so at one point I was brave enough to decide I was going to go to aerospace engineering. And I did it, and I made it, and I still had some dark periods in engineering too, because engineering is crazy hard. But I mean, having this dream helped me so much, because I always had something to strive for. And so that was really what prevented me from dropping out or giving up, you know. So that's why I always say that having a dream is so important. No matter how hard it is, no matter how far it might be, it doesn't matter if you're never going to get there, but do follow it, do try it, because it will help you so incredibly much. And then you never know where you're going to end up. I wouldn't be here talking to you if I hadn't followed my dream in the first place. So yeah, I think this is pretty important to talk about. I think you're muted. We can't hear you.
Okay, I'm sorry. That's my bad. Okay, you came really beautiful place that you can ever come. So believe me, it's so beautiful to talk to you here about space, and to see that people all around the world is just following their dreams. It's too beautiful for me. And as I can see that youth is really into the space things, it's just so honorable for me. And of course, it's probably honorable for you guys too. And is there anybody who wants to ask some questions to the speakers? Nobody?
Actually, I have one question.
Okay.
I don't know much about going to space. I just sometimes read some articles. So, what is the latest thing you can say? What is the latest news in astrobiology? Because I don't know much. I'm sorry about that.
that was quite a general question. So there were two questions. One is how do we go to space, and the other is about something about astrobiology. Is that right?
I mean, I don't know much about space, so I just read some articles, but I just want to know about astrobiology. I'm more interested in your area.
So I can
Cool.
tell you real quick, the
Go.
reason you don't know much about what's going on is because no one knows about much what's going on. This is like a brand new field. We're all kind of feeling our way around. So don't worry about not knowing what's going on. You can continue.
So
I'm gonna go. I was gonna go ahead and extend that answer, and that is like it's not just astrobiology; it's the entirety of all spaceflight.
Yeah.
Like people are just, yeah.
we are just improvising all the time.
Yep.
And we're just being all very optimistic. Okay, I'm just going to say a few words about astrobiology to give you a general idea, yes. So there are, I would say, two kinds of astrobiology. There is the one that is focusing on trying to look for very simple forms of life in the universe. So something like bacteria, for example, and we are looking for those, let's say, on Mars or on Venus, like we have recently discovered. You've probably heard somewhere, because it's gone pretty viral, that we found a particular substance, this phosphine, in the atmosphere of Venus, which is a biosignature, which means that probably or probably not, there might be some forms of life in the atmosphere of Venus, but we're not sure. So there is this area of astrobiology that is looking for molecules of life, or anyway, very simple life forms. It will be, I mean, it might not sound as exciting as finding ET, you know? Antennas, green little men, and things like that. But actually, the thing is that to date, we have found no proof of life beyond the Earth, like none at all. So once we make that discovery, it will be absolutely historical and mind-blowing, and also we will probably figure out so much more about how life originated on our planet in the first place, because we have some theories about that too, but we're not sure. So this is one. And also, little parenthesis on this one, for example, you know, there is a moon of Jupiter that is called Europa, and it's probably an ocean world, and probably there are probably there is life. There might be. I mean, I like imagining alien dolphins swimming inside the ocean of Europa. Would be pretty cool. But yeah, that's also astrobiology. The other part of astrobiology is it's more close to science fiction, I would say, and it's searching for intelligent alien civilizations, which obviously we haven't yet found. There is program that is called the SETI program. I don't know the English pronunciation of that. SETI, I guess. That is it has a huge radio telescopes, and it's trying to capture radio signals coming from space in case some alien civilizations are trying to communicate with us. And we have also sent some messages into space in case there's anyone who's listening. But yeah, nothing has been found so far. So yeah, this is pretty much what astrobiology does. If anyone wants to add anything, just go ahead, I guess.
Now I just have one more question. I know I'm
Sure.
asking a bit much, but I want to ask which theory that sounds more scientifically accurate to you about the beginning of life, about how did we came to Earth? I mean, it's just something personal, but Yeah, I just want to know your idea.
It's not like I have a personal idea. I mean, if we talk about how life first formed on planet Earth, like there are some theories talking about hydrothermal vents on the ocean floor, or some I don't remember exactly, but something related to oxygen or hydrogen and some chemical reactions that started in the very beginning. Things like that, anyway. We're all
By the
the
way,
result
thank
of
you
some
for answering my
chemical-
questions.
You're welcome.
Anyone else?
For Ali Khorshidi Benam. Do you hear me? Do you hear me?
We can hear you.
Okay.
Yes.
I wonder.
Can you hear me?
Yeah, I wonder a little bit about in your country. What is there like improvement about educate young people about space and science? I mean, is there like a dominant space curiosity with the young people?
Yeah, absolutely. We are working on it. Space technology is not new in our country. Maybe back in 90, but recently, as you follow, if you follow news, you can see some activities about space in our country, sending satellite to the orbit, mostly in LEO or 200 or 500 kilometers. But the people and of course kids and youth are really, really, really interested in space science, and they are really curious about this field. And as I said in my talk and in my panel, we are working on it to holding some special courses and special online courses for more promoting space science in Iran, and we are working on it. And recently we will hold a pocket cube competition, and we are in the proposal phase in the competition. So students, I mean university students, can participate in it, send us their proposals and prices, build prices, and in the other phases we can help them financially and technically to build one, and we hope that we can send it to the LEO orbit by the next year.
Thanks a lot for